Alright, so this video is going on the eyes. So there's 3 levels in your eye, 3 kinds of cells. There's rods and cones, RNC right here. There's the bipolar cells, and there's the ganglion cells. So here's what's going on in the rods and cones. You're going to perceive light or dark. So let's start with the dark first. So in the cell there is something called GMP, and we have a protein that will turn it into cGMP or cyclic GMP, and is being turned into by guanylyl cyclase. And so what cGMP does is it's going to come onto this little channel here, and it's going to open it, allowing is a non-selective channel, and it will allow any kind of cations in. For example, Na+ and calcium. There can be more that's coming in, but these are the 2 main ones that will be coming in. And so normally we have sodium, which will depolarize it, and we have really calcium, which is known for releasing or allowing for exocytosis. And so what we do is these synaptic vesicles within the cell will come out because this calcium is coming in, which will allow for these to come out, and this is called glutamate. So glutamate is being released by in the dark. Another thing is, since cations are coming in, the normal resting potential is -70, right? -70 millivolts. But now positive charges are inside the rods and cone. So instead, in this case, it will be -35 millivolts. So that is important for later. In the light, there's some slight differences. So there's light that's coming in. It's going to interact with this green one, and this is called rhodopsin. And what rhodopsin does is it will interact with this one, which is transducin, and transducin will interact with these pairs of scissors, which is called cGMP phosphodiesterase. Let's write it together. Cyclic GMP phosphodiesterase. There we go. That's what this pair of scissors is. What this does is it turns cGMP to GMP, all the while this guanylyl cyclase is still doing GMP to cGMP, but because of the scissors, it's turning back to GMP, meaning there will be no cGMP inside the cell, and this cation channel will be closed. What does this mean? This means that the normal resting potential for this one is going to be -70 because there's no cations coming in, and the synaptic vesicles stay inside and they're not being released. Glutamate is not being released, and that is important. Well, why'd you say that? Well, this is how the cells interact. So you have rods and cones, you have bipolar cells, and you have ganglion cells. And so what's going on is, let's see, you have a little neuron here, here, and here. You have a little neuron here, here, here. So these are the rods and cones, these are the bipolar cells, these are ganglion cells. And in the case with light, in the case with dark, what's going on is it's sending the glutamate here, but there's no glutamate here. And so because of this, there's different interactions with the bipolar cells. But there's two kinds of bipolar cells. There's this blue one and there's this red one. And this red one is constantly firing glutamate, but in this case, this blue one will be firing glutamate in the dark. And so this is when I'm going to get a little more specific about the bipolar cells. And also, when the ganglions are getting these signals from these two bipolar cells, let me write that in a better color. If these ganglion cells are getting signals from these two, it's firing an action potential, AP. Alright, next page. So there's two kinds of bipolar cells. There's the on-center, and then there's the off-center. So next scenario, dark and light, and this is going to be a scenario with, again, dark and light. Alright, basically you have the rods and cones. Remember that this is going to be -35, and there is signals being sent to this here on center cell, and that here you have the light rods and cones, which is not sending a signal. And then let's just go with this for now. So the on center, and then there's the ganglion. Let's draw this as a square. There you go. There's the ganglion. So what's going on is there's a metabotropic on the on center. There's a metabotropic receptor, and it's going to be a whole cell cascade telling this to stop sending glutamate. And what this is, and in this case, there's no glutamate, and so this receptor is not doing anything, and therefore glutamate is being sent. The bipolar cells are releasing glutamate to the, would be releasing glutamate normally, and since there's nothing to stop it, it will fire to the ganglion, and the ganglion will fire an action potential. So then in the off center, let's draw this again. Draw this again. These are the same molecules. It's just so these are R and C, bipolar ganglions. Alright, so in the off center, remember that in the dark, it's always firing, it's always sending glutamate, And so this time there's an ionotropic response receptor. And so what this is doing is that is telling the ionotropic response, the receptor, to open, letting cations in, and again, cations means calcium also, and so the synaptic vesicles within will release, sending glutamate to the ganglion cells, which will turn into action potentials. And so in the light, if there's no signal, there's no signal here. Wow, this is confusing. What am I looking at, right? You guys are probably thinking that. But something I just realized in the shower while I was thinking about this, in the on center, think of it as on. So these bipolar cells are in the center, right? These bipolar cells are in the center, right in the middle of the kind of cell interactions. And so if it's on, that means it's sending something, right? But here in the dark, it's being inhibited by the signal before it, so it is turned off here. But think of on as always sending. And so in this case here, where it's always sending, right? Unless it's getting glutamate. So in this case, so if it was getting glutamate, that means this would stop sending. So it's always on unless it's getting glutamate, which, and the only case it'd be getting glutamate is in the dark. And I think of off as not sending. So this means that no glutamate here equals no glutamate here. Whereas in this case, where there's glutamate, turns into glutamate and turns to action potential. I hope that helps, because this this can be kind of confusing, and if I didn't have that shower thought, I would still be confused right now. And yeah, that's it for the dark. For the eyes, I guess some fun facts would be, if you're colorblind, like my friend Richard, you're missing one type of cone. And so there's like, here's like normal vision. Like there's like a graph. And so like here's like normal vision. Here's like RGB vision. And like here's the, I guess the G vision. And there's the, I guess the B vision. Is like kind of what I remember of it. And so if you're colorblind, you're missing one of these, and it's like, wow, Richard, you suck. And yeah, that's my fun fact, and this is how the eyes work.